So Henka just went through tricks for visualizing static maps, and I'll walk you through basics of making interactive maps, kind of JavaScript maps based on Leaflet, using a few Python modules. From last year's materials, if you are, let's put this to master branch. Yeah, so last year we went through a bit more in detail this Poke. So if you want to have a look at that, feel free, but this year we left it out because it's not apparently developed so much. So it's a module for creating like zoomable, panable plots, and the plot can of course then be a map. Interactive plotting. So let's go. I have it open already in here. Interactive maps on Leaflet. So I kind of wanted to start with an example. Some of us who are Finnish read the Helsingin Sanomat often, so this was a news about, it's kind of sad news, but maybe for geographers quite interesting. There was this dude who went to the island with this very isolated tribe, and he got killed. So it's quite typical, and this is how the place looks like. So nowadays it's quite typical to see these well, embeddings. There's his Instagram page, and then there is just an interactive map showing the location of this North Sentinel Island. So it's somewhere there, east from India. And when you look at these maps, first of all, you can see that there is OpenStreetMap as the background, and then there is link to Leaflet. So this map, it's an interactive map. This is an HTML web page basically, and then and it's at least partially based on JavaScript, and then Leaflet is a JavaScript library for mapping interactive maps. So we can interact with this block of the web page, we can zoom in and out, we can pan, and then there's some kind of this is a very simple map with one marker, and then there's this kind of a location or index map in there. So this is something, or the type of maps that we will now learn to do. So as said, we'll do maps with Leaflet, which is a JavaScript library, and JavaScript is a programming or scripting language. So we are now on a Python course. We won't be learning JavaScript, but it's good to know. It's good to know that the outputs are then actually converted to JavaScript. Leaflet is not the only JavaScript library for interactive mapping. So another option, for example, is then OpenLayers that you could use. But these modules that we're using today are then linked with Leaflet. So we'll first have a look at a module called Volume, which kind of, well, the point of these both modules is that we take the advantage of kind of processing data, wrangling data in Python using GeoPandas or whatever we like, and then we take the advantage of Leaflet mapping capabilities for then rendering online maps. And then the MPL Leaflet, so there you can kind of create your plot using matplotlib that we have already learned in period 1 and this period, and then convert that matplotlib object or the one subplot into a interactive map. So those two modules. Yes. So let's continue. You should have the empty notebook available. If it doesn't have a kernel, do put it. Mine didn't have. So we'll start working with the lesson contents. Actually, before we start to do any coding, we could still check what Volume is about. So it has quite good documentation, and then there's a gallery of examples for doing these simple maps that we have here with just a marker, but then we can do quite fancy things such as heat maps, or then zoomable kind of clustered maps where the content changes depending on your zoom level and such. So this is the basic documentation in here. And basically today we'll at least use the mapping function and then a few plugins that are then linked to JavaScript plugins such as the heat map plugin. And then in the example gallery, part of our lesson is based on these examples. So then today we'll make, for example, a simple heat map, but you can also make a heat map, kind of an animated heat map with a time component if you like. I don't know if this is now showing, yeah. So something like this we can quite easily do using Folium linked with Leaflet. Great. So of course first we need to import the module, and then we'll start just by, in the first part of the lesson we maybe started first from the data, but let's just kind of create a canvas or an empty template for our map, on top of which we can then later add data. So we'll store the output in something called M, so that would stand for maps, the map, and then we'll use this Folium .map class, which takes specific parameters. Maybe we could check. Well, let's check a bit later. We'll first of all we'll define a location. So we'll set the kind of center point around which the map will be visualized. So that will be something, and then we'll set a zoom level as you did before. So at what level we'll start zooming, and then we can add, I'm not sure if this is necessary, but control scale equals true. Okay, so then the location, that is a list of coordinates. So you can of course choose something else, but let's put some coordinates that are located in Helsinki. So the latitude and longitude, decimal degrees, and then we can select the zoom level. Let's test with 10. So that's giving some errors, but let's not worry about those. So this is a bit slow now that we're working on Binder. I think it might be a bit faster in the CSC notebooks. Yeah, actually now it's only here created, and then we need to call the map object to render the map. Okay, it wasn't that slow. So this is kind of the very, if we would just want to, we make a blog post, we want to show Helsinki, we could do pretty well already with a map like this. You can zoom it, and then of course you can test what if we change the zoom level. Let's zoom in a bit closer, rerun this one, render the map again. So then you get a more zoomed in map. Yes, so that's the basic thing. Let's make another version of the same map. Actually, first we wanted to save the map, sorry. So what happens actually in here, of course we get this nice map plotted here, but you can also save it as an HTML file. So let's see what happens there. Output file path, base map HTML. And then there's a method called save in the map class of Folium. Let's see if this bugs me. Yeah, so this is something that I just figured out over there. It's maybe something related to is it? FP. Yeah. Kiitos. Well then.
You need to refresh probably there on the.
Yeah. No, it's there. So it's just a bit slow. So what we get as an output, if we save the map instance, you can double click on this file, so it opens it in a text editor. So this is actually then the HTML file with everything we need to render the map. And then if you click open in new browser tab, so then you can get the map as a kind of HTML page that you could publish online if you wish. So in comparison with the maps you did earlier, so it depends on the purpose. So if you're making a map for your publication, you might want to do it the way Henrik showed earlier, but if you're from the start making a map for your blog post, or you're opening up some data, you want to publish the data there, then you might want to start from this perspective, that you want to create a nice map that can be published online. Okay, any questions about this? How many of you has done something with leaflet, for example? I bet none of you, yeah. Cool. Okay, so indeed what I wanted to do is to make a bit different version of this map. I just copy pasted the first version of where I create the map instance, so we could change the location. Let's see where these coordinates take us. 73 maybe, and then minus 73. Okay, so as you did before, let's actually check this now. So in the class, when you initiate the map, there are some parameters that we already used, such as the location, and then the starting zoom level, but then there's also a parameter for selecting the tiles that we are rendering, and by default the tiles are OpenStreetMap tiles. And below here you can see the list of other built-in tiles you can use, so a bit in a similar manner as with the static maps. So we could add here a parameter tiles, and for example test the Stamen toner style type, and see what that gives us. Let's also render the map. There we go. So we're somewhere in New York, and we get a different type of map. So if you wish, you could have a bit better look at this documentation and test maybe the different background maps. You can test different zoom levels and such to select how the map is initially initiated. Of course, when then the user interacts with it, the contents then change, especially the zoom level in there. But maybe we'll now go a bit forwards, so you can then practice and modify these parameters then in the exercise. Okay, but when then we have the base map in there, out of the options, we want to of course add some layers to the map, and preferably some analysis outputs. But let's first see a very simple example, a bit somewhere along the same lines as the newspaper map. So we want to provide a map with some marker on it showing a place. Again, something useful we could have on our websites. So again, now I'll do so that I copy paste this code where we initiate. Actually, I'll copy paste this Helsinki code from here, get the coordinates. So we could, for example, make a map where we show where we are right now. So let's put a marker on top of Kumpula. So in Folium, there is another kind of data type or class called marker. So we'll use that to add the marker on the map. So we call first folium.marker, and it also has the parameter location. So I checked this beforehand. So we are somewhere around 60.20426. We can then adjust it after we're done. 24.96179. Then we can add some text using a pop-up. Kumpula campus, and then we can add an icon, so the actual marker that is then rendered on the map. So folium dot icon, capital I, can set color and then icon type. So as the color, we can put green, and then this is at least something that works. So that's it. So with this syntax, we kind of create a class object which contains the marker and its kind of attributes, and then that one we want to add to our map instance like this. And then let's see how that would look like. I'm missing some commas. There we go. Yes, let's still change this. Maybe I'll put that one as well. 96, so that we can actually see our marker. There we go. So let's see how well we did with the location. There we go. Well, I think it's good enough. You can then adjust the decimals. Are we there? Yeah. Oh. Almost there. So, but you get the point, I guess. So, of course, then you can do tricks, change the marker color and such. So there is, if you run help folium.icon, so you get some tips of this class, the parameters which we used, and then icon, see font awesome website to choose yours. So if you want to explore, you can see these tips to make another kind of marker, for example. So help and then the constructor name. Okay, that's it. But then eventually what we really want to do is to do some cool data processing in Python and then add those maps onto our web map, right? So next we'll take as input the address points that we've used in many exercises. So you should have them here in the data folder, and the code is here ready just to save some time. So let's read the data, import GeoPandas, read the file path, read the data into GeoPandas geodata frame, and let's check what we have. So it's the addresses, and this data, if you remember, so it's the addresses of the transportation locations, so basically train stations and such in Helsinki. So this is now the point data we're working with. And eventually what we're gonna do is to add these points to the map. And for this purpose, now we need to convert the points into GeoJSON. Which we'll do in the following way. There's a few different ways you can do it. Maybe I'll first just show one of those. So points GJSON, for example. So we'll store the output in there. And then there is in Folium, there is a constructor, Folium features GeoJSON, and that takes the points as input. So we can do it like this. Maybe I'll just put it here. You have it also in the web pages. So you could do this kind of points. Well, I'll just say so points to JSON. So there is a pandas method for converting the points to GeoJSON, and then use that. But well, let's now stick to this. I hope I'm not typing too fast. Points. We can see what we have in there. Well, this now just renders the Folium data type. But that is the required input for then the next step. So again, if we have, let's recreate this map instance to get rid of the marker that we already have in there. So I again copy-pasted the same code now that we used a few times. Maybe I'll put the zoom level back to, well, zoom start is 10, that's good. And then I have the points in here. So I'll copy that, and then again I can add to the map instance. There we go. Yeah.
Does that modify an object, or is it just this one time it's going to show these points?
You mean this one here?
No, the points GeoJSON add to A.
Yeah. Yeah. So at this point, so if we wouldn't have this one, we run the code. So we just have the background map, right? Then we have in memory, we have the points that are converted to Folium data type, kind of GeoJSON type data type, which we add to the map object, which we then show here.
So M is actually modified, right?
M. So at this point, M is it's an object that contains the kind of way in which we want to render the map. So I'm not sure if I'm answering your question.
So in the manner as with the GeoPandas, we have the axis. So the M in here is basically kind of the axis.
Yeah.
So
Yeah, it's kind of the we could call it a subplot or the map plot in here. So I commented out now the add to, and then using this, I have this object, and then this is kind of like I set that please plot those points in the same subplot where I already plotted this base map, if we're using kind of this matplotlib concepts. Yeah, we could see, I'm not sure if there's where is the documentation for the add to. But here, well, maybe we can then post it later to Slack, but the idea with this, or when we're creating maps with Folium, you kind of start thinking from the point of view, like from bottom up. First, let's put the background map, then you can add add things on top of that map. So kind of plotting. Did we answer your question somewhat?
I guess I can see it now.
Yeah.
M now has these blue points. If you call M again, all the blue points will come up.
For sure. Yeah.
Which
Yeah, so
some functions we use, that's not the case, right? So
Yeah, for example, with matplotlib, so if you would call it again, you don't have it. Look at that.
yeah. So now if I call M again here, I have the latest version of M in the memory, and it has the added points in this figure object.
Yeah.
Or interactive map object. Yes.
another quick question was,
Yeah.
does Folium work only with decimal degrees, or if you have data sets that are meters, does it also?
Folium, now you correct me if I'm wrong, but I think it requires VGS84 as input. You can then, I think it only supports that. Yeah.
Most probably decimal
Yeah.
degrees might be with the web mercator as well, but at least those.
Yeah. Let's check that.
Quite often when doing these kind of interactive web maps, so it's most often they are decimal degrees always.
So then you get this like Mercator world map if you zoom out. In this case. Okay. But let's check the projection thing. I'm pretty sure that then it's also related to leaflet a bit. Maybe you could give some parameters related to them. Projections. Okay, but now we have a base map. We have points on the map, but of course this is not yet super fancy. This might give us some information, but not yet too much. And then you can imagine you can then adjust the colors and such of these points. But let's see how then we could visualize these maps as a heat map. So Folium, oops, where is my one file? Let's hope. That's pretty typical. Well, let's see what happens if we continue. So Folium has certain plugins that are then of course related to the plugins that are available on Leaflet. Let's open that quickly. So there's different plugins available, but we're here using a plugin called folium.plugins.heatmap. It takes some input data, and then there's specific parameters you can adjust. But most importantly here, we can see that the input data needs to be a list of points or then a NumPy array. So we'll need to somehow fix our data to meet these requirements. Yes. So, well, I guess you could do this in a few different ways, but I resolved it like this. So we have the points data frame, and we don't have here now separate latitude, longitude columns. So of course we could then use those, but we have the shapely geometries in there. So to kind of do it step by step, I would want to extract the longitude and then the latitude from the geometry column. So for example, I can do it like this. So I have the geometry column, then longitude, latitude. So longitudes are the kind of these coordinates. I always have to think that. So kind of the x, if you go to the east, then the longitude changes, and then same with the latitude. Leveyspiiri in Finnish. So then it's the y coordinate. this was, for example, I think it was exercise 2, some of you got these mixed up, so then the map was kind of 90 degrees the wrong way. And then, so then we would have this points head. So those separately, so these are now just floating point decimal degree numbers as floating points. And then I'm now going for, so the plugin required a list of points or a NumPy array, so I decided to make a NumPy array, so points array equals to points. So I'll just take these points inside a list, so subset only those columns from the data frame. Is this now, so in the order latitude, longitude, and then the values of those, so this actually values type points array. Okay, so by doing this, pandas returns me a NumPy array of those columns, and then we can still check, now that we have a NumPy array, we have to use this syntax to get the, for example, first 5 kind of rows of the data. So there we have a NumPy array with the coordinate pairs. Do you have questions about this? So this is one of the types of inputs the heat map allows. So let's check, the output was supposed to come here. So let's do this like this. Okay. So then from volume plugins, let's import the heat map plugin. And then again, I'll do one more copy paste. So I'll take this again, create the kind of map canvas or map instance above which will then plot additional things. So the M, and then the next step is to use this heat map plugin to create the heat map layer. So we can call, now that we imported it, we can call heat map and give the points array as input. That's actually all we need to do. You can then play around with the other parameters if you want. And then the same way as we did with the GeoJSON points, we can add this then the heat map instance to the map. So let's see, let's hope this is quick. Okay, there we go. So once you get it done, you can zoom in and out, so you see that the map is visualized based on the zoom level. And then our map tells us that Helsinki city center is the most dense when it comes to the input points or transport data. Of course, it depends how good the input data is. Did you manage to do this? Yeah. So now you can, I hope your kind of imagination starts thinking that what all sorts of data could you visualize. If you have some, you could have some field data if you're a physical geographer, or pollution data, some point observations, then we could make a heat map out of those. There we go.
So I didn't miss, what is the intensity visualizing here?
So it's a visualization of, it's kind of the density of the points. So we could also add a weight. So it's kind of under the hood. It's kind of converted into a grid, and then there's some kind of a calculation. And then these parameters you can, I think you can. You can adjust the radius, for example, within which the density is calculated. Yeah.
I'm not totally sure, but I assume that they're using this kernel density estimation basically. So whatever kind of point find the heat maps.
Yeah. Well, I didn't check beforehand the leaflet heat map documentation, but I'm sure we get more
Yeah,
more
get it.
details from there. But this is something you'll also find as a tool in ArcGIS, and of course it's good to check a bit how the calculation is actually done. Okay, other questions? Yeah. Oh, there's a typo, I think. So correlate map, so thematic maps, we can also do. So I'm now a bit slow, but anyway, here we would want to visualize the population data, which is at least one of the polygon data sets with attributes that we've used. So it's now not, that input data is now not in the data folder because it's a bit massive. So let's quickly re-download it unless you have it in your own computers. So what we want to have is the väestötietoruudukko, so the population grid 2017. I'll go through this quickly and then let's have a little pause that everybody gets the input data. So I need to work a bit in the terminal. So first I check where am I located, and I want to navigate to this lesson 5 data folder. So CD notebooks. Hello. Then inside there, CD lesson 5, and then CD data. And I copy pasted this massive link from the web page. It should work. Download the data in there, and then you can unzip the data as well. So I should have the shapefile inside POP17 folder, after which I can then return here. Maybe Henka can check if there's any problems. So navigate to the correct folder, use wget URL link, unzip the file. And eventually it doesn't matter where you extracted it as long as you then update this file path correctly. So I have my data inside data, POP17, then let's check what's the actual name of the file. I can copy it from here like this. Can I continue? Yes. Maybe? No? Yes. Are you following? Okay. So this dataset is familiar from lesson 3. And we read it in with GeoPandas, check the file. So the asukkaita column in Finnish population contains the population for each statistical grid, and that's something we would now want to make a quick visualization, an interactive web map out of. So indeed, we just discussed projection. So we want to project the layer into VGS84, and I have the code ready here to save us some time. But what it basically does, it takes the data frame. We have it stored as a GeoPandas geodata frame in the variable data. Using the toCRS method, we specify the EBSG 4326. We can check what that produces, and then for this example we are also subsetting the data. So we take all the grid cells which have some population, and then which have less than 1,000 inhabitants. We can then modify these later once we tested that our code works. And then importantly, we create an ID which we need to pass for Folium. We can check a bit later why. So we create a new column GeoID, which basically just takes the index of the data frame, and then finally we kind of drop off or only select those columns that we want, slicing the data, and then we could, for other purposes, so some of the methods can deal with pandas data frames, geodata frames. In Folium, some other methods require the GeoJSON input, but for this example, we can actually pass the data as a GeoPandas data frame, and Folium can handle that. So let's see what we end up with. So in the output, we have the GeoID in a column, then the population column, and then the polygon geometries of each grid cells. Is this clear? Yeah. Okay, so then we can actually do the mapping. Let's see. Server error. Once more, I do yet another copy-paste of this map because our data is again from Helsinki. And I want a clean start. So I create a map instance with the same location, zoom start. Of course, if you wish, we can then, for example, change the background map. A bit later. By default, it's OpenStreetMap, so maybe we want something more simple as we're visualizing data on top of it. So we could use. Oops. There's something called Carto de Positron. So a map tile provided by CartoDB in the default map tiles. So let's just show that first before we plot the data. Yeah, I think I'll take 10 more minutes still, but I guess that's fine. Okay, so this would be then our background map for then a thematic map that we want to put on top of it. Okay, so eventually we will create the map using the Choropleth method. The documentation is here. You can have a deeper look at it. But most importantly, it requires some data. So from this documentation, we can see that it takes a JSON file or even a GeoPandas object. So which it then converts to GeoJSON geometries in the output map. And then, so that's the geometries, or then the spatial definition. And then, in addition, we need to define data. So what are the actual attributes? We can also specify columns in there. So at least those parameters we will need. Where am I here? And I will do now, just to avoid typos, so sometimes if you use a method which has many parameters, so you can just kind of copy paste all of it and then maybe drop out the ones that we don't want. Of course you can type in Choropleth, then all the parameters, but I'll do it this way. Now, so let's put it in there and then start modifying. So actually how we want to call it, I just I'll fix the lesson materials afterwards, but we'll want to call Folium.Choropleth as a constructor. And then let's see which ones of these parameters we actually use. So the geodata at least, so the geometries, and what was the name of our variable? It's data, so geodata equals to data. So the Choropleth map will take the geometry, so the grid cells from that layer. Then will also specify data, so we want to also render the attributes, and there we actually have the same data. We could have a different, we could for example have a pandas data frame or some other source which is then linked, but now we use the same source. Which columns? So there is the geo ID and then asukkaita, unless you have renamed it. Asukkaita, 2 Ks. Yes. Then this is something I think we need. Well, let's check. I think it might also work without, but kind of so key on, so it is kind of the variable in the inputs which links the data, but we'll set it as feature ID. Actually, kind of want to test it also without, if it works. Okay. Then let's leave the threshold scale there, but I'll comment it out because we're not going to set it yet. Then we have fill color. So again, of course, you could set it as blue, but we're kind of making a map with some kind of classification. So here we can also set fill color, line color, fill color. So we can pass one color, or then some of these kind of predefined color palettes in there. So I'll, for example, pick this one. So you can check from Color Brewer what these codes stand for. Then test those. This is yes, I'll do that. So opacity, well, we can play around with that. Line color, maybe white so it doesn't dominate so much, so the grid lines. Line weight, or maybe we take them out, let's see. Well, we can maybe just soon plot a map and then play around with the parameters. I'll still set highlight as false, smooth factor as 1, reset. The rest we can leave as default, or then take them out. Maybe legend name. So what are we plotting? We're plotting the asukkaita column. So sorry?
Population.
Yeah, population, exactly. Population in Helsinki, 2017. That's what we're plotting. Did I miss name parameter? Well, let's see what it affects here. I have it as okay. Well, let's go ahead and plot this. So we have the map instance, so the base map we already tested, and then we're creating this Coroplet object in a way, and in a similar manner as with everything else so far. So we want to still add to the map. This might take a few moments, but not too long. It's proved to have worked. And then sometimes, especially if you have trouble rendering the maps in the notebooks, or also otherwise, remember that you can then actually save the outputs as HTML files. Let's see, is this connected to the internet? Yes. Python tree. I hope I have the variables in memory. I'll rerun from here. There's some server error. Is it working for you guys? Doing something? Yeah, okay, good. This isn't. Let's maybe. Is it connected?
Probably if there's the button for Wi-Fi.
Yeah.
If you click that off like all. Then if you put a new Google tab, just a bit. Yeah.
Should work. So I'll start from. Maybe I'll just restart this. I'll need to import the modules. You can also check from the web page is the correct or some version of the parameters while waiting for this thing to magically reappear. So okay.
Yeah, if you don't see anything, you just see white space. It might be something related to. So it works well with the Mozilla Firefox, but for example, Google Chrome, for some reason it doesn't.
So you can change browser, but one thing you can also do to check your output is to save it. So outfp correlate map m.save. So now we're saving the most recent version of the variable or the object m, which is our map outfp. So I think even though if you don't see it here in the notebook, if you do this saving thing, so you'll get the output underneath here, open browser in a new tab. So you should see it here. Who didn't manage to get a correlate map? So if you have this HTML file, if you double click it, it will open it in the text editor. But if you right click open in new browser, you're supposed to see something like this. Did it work? Yeah. Yeah. So this is already quite neat, and it has automatically now classified the data. So the darker the red, the more there are people living in that grid square. There is this parameter that I now left out, which is the threshold scale. So this is one of the ways you could modify the bins. We could try it now, but there was something weird that happened. So let's not get stuck in here. I can maybe post later or if we figure out the thing. But for example, we could we could set some cutoff values for the visualization. I think we have only less than 1,000 inhabitants, so let's see if these would work. But I think something weird happens with the colors. Yeah, I'll get back to this. But that's the parameter you can use to set the thresholds. Question? Yeah.
Yeah. Is it important in which order you have the parameters when you do that?
No, as long as, so this is kind of basics of calling a function or a method constructor. So if you do like this, that you set geodata equals data, data equals data. If you always have the name of the parameter that is in the documentation, and then you, so here geodata equals whatever you assign the value as, data equals, so here you can see that the default value of data equals none. So if you wouldn't define the parameter, then it's none. The order matters if you don't say geodata equals something, if you would only put like population grid. Okay. Yeah. But this applies to whatever function you're calling or whichever thing. Okay. Yeah. Still a few more things to show related to volume. Yes, let's go through those. So still to kind of make, so indeed here then you can tweak a lot of things. You can change the colors, you could change the thresholding, all of these things. But maybe, well, I'll leave it up to you to explore, and maybe also to us to explore these a bit further. But it's quite straightforward at the end. Final thing with volume that I wanted to introduce, which we also did last year, it's more related to the points. So there is a way or a plugin in volume to kind of cluster the points. So if you zoom in, the points are visible on their kind of exact locations, but if you zoom out, you get a clustered visualization of the points. And that's called marker cluster plugin.
It's really useful if you think that you would, for example, have a map of, I don't know, all gas stations in Finland, for example. So the idea that you quite often see when you use some map applications, that because there are so many of those points, so you don't actually want to show all of them on the map. Instead, you want to have some kind of clusters, and when you click on those, then you get more and more.
So something like this, when you're more zoomed out, you just see, oh, there's 126 points, and when you zoom in, then you actually see those points. So let's quickly see how you can do this kind of a map in here. So we first import the marker cluster plugin in order to do this, and then this is also maybe a bit cryptic before actually seeing the output, but then we have, so now what we'll want to eventually do is to plot on top of this choroplete map. Now we'll put another layer with the clustered points. So now actually I won't copy paste the M, so I now have the map instance with the choroplete map in memory, and then I'll just do marker cluster equals marker, or I could do M equals, but let's create a new variable, marker cluster construct, and add to map. So this will then be another kind of volume map instance then with the capability of creating, when you zoom out, if there's points, they'll be clustered. Okay. Then let's see how to explain this quickly, but then we'll kind of want to iterate the points that we have. So we'll again work with the points layer. Oops, address points. Oops, And then I need to run those into memory. Sorry for these inconveniences. So from the addresses.shapefile, we have the points in there. And then again, well, I could also use the previous version, but I want to fetch again latitude and longitude, and then add those coordinate pairs to the map. There's different ways. Perhaps you could do this, but we'll just do the familiar iterows approach for accessing each row in our data frame. So iterows. So for index row in points.iterrow, for each row we want to get the longitude and latitude. So we have row geometry, again longitude pituuspiiri is the x, and then latitude leveyspiiri is then the y coordinate. And we can also, if we want, fetch the address, so actually add the as kind of a pop-up for then each of these points, then the address as a text. So now for each iteration we have latitude, longitude and address in variables, and then let's just go ahead and type this in and see what it does. So we'll now, instead of just dumping all the GeoJSONs or lat-long pairs to the map, we'll add them as polygon markers actually. And for each row we set the location as latitude longitude pair. We can add a pop-up again, which is then for each the related address that we stored in the variable. Then we can add some kind of a fill color. Can use the one in the lesson materials or something else. I guess we could put something easier. On 2 lines. Add to marker cluster. Have a look at the documentation a bit. So if you want to have a better look of the parameters and what they do, you can check this volume features regular polygon maker. But maybe we'll go ahead and see what it actually does. So after when we do this for loop, we add all these points in there. Marker cluster. Have I not run this one? Probably need to, yeah. It died. So you can already go ahead and run it if you have it in memory. It's taking a while. Okay. now I have the background map, the complete map. Then I take that, create this marker cluster map instance, and then add each point on top of that one, which we can then visualize soon. So this one now shows the, let's see, yeah. So now that I'm in the start zoom level, I see how many points are there, and then the polygon that is rendered underneath shows kind of the extent of the original points. But if I would zoom in, then kind of the extent from which the points are clustered changes automatically, and finally then when I zoom close enough, I can see the original points on the map. Yeah, so this is maybe one of the examples you need to first type in and then see a bit what the regular polygon maker, for example, did. Yeah. There we go. Is there questions about this? This is maybe, hopefully it kind of gives you ideas and inspiration, and then with the exercise you can read the docs a bit further, tweak a bit the exercises, test different input data and such. Yeah. Okay, that's it for Folium. This is a super quick example. I've been taking quite a long time, more than I promised. But finally, now that we spent so much time learning how to make fancy plots using Matplotlib, there is also a way where you can kind of, with one row, turn those maps into interactive maps. So I'll show a quick example and then leave you to play around with it. So the simplest example I came up with is we again have these points, hopefully in memory. I'll just first start with this. So of course, so this is now a geodata frame, and we can do points.plot, which plots the data. And normally, if you don't get it right away, you'll do plt show after you have imported Matplotlib. So that's the very basic workflow. But then there is this library called MPL leaflet, which indeed takes whatever Matplotlib visualization you have done and then turns that into a JavaScript version of it. So I think I found that the documentation wasn't maybe super informative, but there's only a few commands we actually need to do. So then the workflow is kind of that you visualize, do whatever visualization, process your data, and end up with a Matplotlib figure, or basically a subplot. So plot your data, and of course, as GeoPandas works, uses those the same functionality, so we can just also call geopandas.plot, and then instead of calling this pyplot dot show, there is something in this a bit similar in this MPL leaflet library, which is then logically MPL leaflet dot show. Now I found that in Binder it doesn't necessarily then show it. If I run it on my own computer, this command would open up directly a new tab with the map, but we can give a parameter path. Actually, it does it in here. So what it does when you call MPL leaflet show, so it creates, in a similar manner as Folium, the HTML page, which you can then open in a new tab. Of course, then we could start modifying our plot, so you could change the color, marker size, for example, make a bit bigger dots, save them as red. Did it already make it? Something like this. So this is something then you could test out a bit on your own. So maybe you can take some of the plots that we already created during the class and then call MPL leaflet show. So this is maybe a bit different way of thinking. So you might want to nicify your map. You have it in your master thesis or somewhere, and then you want to publish that map. So you can then do that by using MPL leaflet show. We can also, now that we're working with Jupyter notebooks, render the plotted data inside the notebook. There we have to call a different method, which is called MPL leaflet display. It takes parameters, so which figure do you want to plot, and then here you can specify which coordinate reference system to use. And how we can then link this plot that we did with the MPL leaflet display. So, well, we can call it as AX, or kind of the subplot, or then you could call it my map, whatever. Store it in a variable, which then contains the matplotlib object, and then plot it. Zoom. Is it then? There's now something funny. Demo effect. Let's even take this. Aha, yeah. So in addition, you need to, from this object, actually fetch the figure. So ax.figure or mymap.figure, then it works. So you have it in here, and again you can interact with it. So I earlier today I tested, so one of these, the basic maps you did earlier today. So this part in here you can replace with whatever plot you come up with, and then render it in an interactive version. Good. Questions? Okay. Then there's still a few things I think Henka will go over. So sharing interactive maps, should we quickly first just introduce the exercise? We haven't published it yet, but I could walk you through it. So your task is basically to create a static map and an interactive map, preferably two different maps, because as we showed here, of course, you can then just publish your static map as interactive, but think a bit about the purpose of the map and the audience, and would it be for a website, then maybe you use Folium or these sorts of things. So we have, let's go here, AutoGIS, I think, no, what is it? Okay, so we'll publish this maybe later today. So first of all, we would want to get some feedback from you guys. So there's an e-form for that. And then two problems. One, visualize a static map. So you can use all the data we provided during this lesson or during the whole course. Visualize those. For example, you can take the dominance areas, revisualize those nicer. Same with problem 2. So visualize an interactive map. So of course you can put some effort into the data processing parts of it, but feel free to reuse some of the examples from this course. The point is then that you would play a bit around with the parameters, go through the module documentations to maybe first recreate the stuff that we did today and then modify those into your own map. Maybe we could add a point, maybe like provide a caption of what the map is supposed to tell and such. But that's basically it. So it's quite, the instruction for this week is quite free, so there's no step-by-step instructions in a way. Okay. But in order to do that, there's something, or if you have this HTML file and you want to publish it to the world using GitHub, so Henka will show you quickly how to do that.
Yeah, so indeed the idea of the exercise is that well, until this point, so you have created a lot of maps, but maybe not taken too much into testing out, like getting nice colors and so on. So now would be the time so that you can really try to play around with all those different figure aesthetics. So like change the font style, change the kind of font size, and play around with all different things, so that you have a bit of time to explore those. But indeed, so one of the ideas in the exercise was that you would create interactive map, and indeed we have the kind of exercise 5 folder in here, and there is a folder in the exercise by default called docs, and this is something useful in terms of actually creating a website for your interactive visualization. So there is a material on the website about sharing interactive plots on GitHub. So basically, for example, how these websites, the website for our course, so this is using this kind of GitHub pages functionality that comes with GitHub, and it's free to use for anyone, basically. But what this does is that it basically is a kind of tool to create web pages, and we can take advantage of that to actually provide the visualizations that we do for anyone in the world. So there is quite a bit of kind of, well, documentation how that works, and there are a couple of different ways how we can actually do these websites using GitHub, but this is maybe the easiest one that is explained in here, and you should basically follow these ones. But the idea is that indeed in the exercise folder, so this is basically how it will look on your own private repository when you have it. So you will have exercise 5 and then the username of yours, and indeed there will be this docs folder, and I will take this away from here. So in this docs folder, so how any website basically, how do they work, is that they are basically looking for this kind of file called index.html. And this is the file. We can take a look how it looks like. Well, this is actually so large that we don't want to take a look at it. But anyway, it has the information in a similar manner as we had in here. So it has this kind of information. So you have the HTML code, you have the head, you have the body, and then you have basically the data possibly inside in here. The ones that we have been using, so using this Folium and the MBL leaflet. So what is kind of a good thing about these two libraries is that whenever you are saving your interactive map, the HTML file that you have is containing also all the data that is needed to actually create those visualizations. And it's okay as far as you don't have, let's say, 100,000 million points. Then it becomes impossible to actually use that. And then you need to have a separate, different kind of approach. So typically your data is in some kind of database, and then you are reading that data and kind of visualize it in that way. But that would require a separate course to or at least a few lessons to go through those things. But for kind of courseworks and this kind of, for example, your master's thesis, if you want to create some kind of nice interactive visualization with
a small set of data. So this is okay as far as you have, for example, I don't know, 20,000 rows of data or something, even polygons and so on, so it's still quite okay. But indeed the HTML is something that will be saved, and we have an example, now it's in here. So we have this index.html file, and by default, if your repository contains this kind of folder called docs, the GitHub basically, so in the GitHub repository you have multiple different tabs actually here, and one of the things that you can adjust and you need to adjust when doing this is this settings in here. And when we go down here, we have a different kind of options what we can modify. But one of the things that is here is this GitHub Pages. And it says that GitHub Pages is designed to host your personal, organizational project pages from a GitHub repository. And here we have a basically option called source. And we can basically, there are a couple of options. So we can use the master branch, so all the files should be on the master, or then we can use a separate branch called GitHub Pages. But then there is also this docs folder. So we can choose that, use this docs folder to actually read the data from that folder and basically create a website based on it. So when I pressed and defined that the source should be this one and pressed saved, now the website basically say that your site is ready to be published at this location. So now what we have here is something that already starts looking quite familiar regarding the website that we use for the course. So we have some https autogis.github.io and then the name. So actually what we will do here is that I can now click on this one, and this looks now horrible, but basically what it does is that it has some text in here, and it actually has some visualization inside here. So this is actually now a map made with Poke, which is the other package that we used, where you can, well, get this kind of travel time map with some hover information in here and so on. But indeed the idea with this one is that now this data that was shown on the website was read from this docs. So the idea with the exercise is that you would basically create and use your imagination and your creativity to create as nice interactive visualization as possible, and basically store that inside this docs folder. And there is an index.md file. So the idea is that you should basically also add a link to this file. For example, here we have the link to the test map, which we can use from here. So you should add a link to the visualizations that you have done. If you want, you can create multiple visualizations, try out different things, and list those visualizations in here. Put links so that we can go through them. But this is now not basically, well, we won't be hard on kind of the criteria for creating. It's just about you to explore different options, and well, what we are basically waiting is that you kind of test out a bit of different things and explain what you have done. But indeed, so this is how you can really easily kind of create personal websites using GitHub. Yeah.
One thing to know, so all your exercise repositories are private.
Yeah.
You can keep them as private, you can also publish them, but then the map that you publish using GitHub Pages will be public. So
Yeah.
Just that you know.
Yeah, that's
Repositories only we can see, but then the HTML GitHub Pages will be
yeah.
out in the web.
Yeah, that's a good point. So indeed, even though this is a private repository here, so if we publish the website, it will be still visible for everyone.
Have to laugh and put to your next job application, check what I did.
Yeah.
Without seeing all your exercise submissions.
Yeah. Indeed. But yeah, so that's kind of a short intro to GitHub Pages. Let's see if there was some additional points in here. Yeah, activate. These figures look a bit funny, but
We can update that.
yeah, we can update it. But yeah, so that's kind of the idea, and you can read more from here. Now I showed quickly how it works, but it should be a fairly straightforward thing to do. So yes, I guess that was all for today. So enjoy plotting out stuff, and indeed you can use all the data that we have went through. If you have some your own data, you can also use that one if you're interested. Maybe in terms of not wasting too much time to actually, because always when you start using some data that you haven't used before, it might require, there might become some new errors that you need to figure out and so on to wrangle the data in a way that it fits nicely. But anyway, you're free to do so if you want. But otherwise, this was it for this week. Next week we will have on Monday the lesson, and we will have a guest lecturer from Boston visiting us, so Geoff Boying, so it should be fun, so there's something extra. And then the practical session this week will be on Thursday normally, but next week we actually need to now figure out how do we do that.
Thursday
It's a national, yeah,
place is closed.
it's the Independence Day on Thursday.
We could also ask Oyedayo and maybe ask me when if we have time for a tutoring session. Maybe then either Wednesday or Friday. But yeah. I'll ask about it. It's like because if nobody shows up, then we don't provide it. We'll ask around. Maybe on this Thursday we'll
Yeah.
ask when would be a good time.
Yeah, it might be, even if next week doesn't fit, we can even do it on the kind of following week, because on the last week we won't have any exercise, so we will see how you can do with QGIS, use Python from there, but there is no exercise for that. So we can even extend the kind of exercise 6 a bit further. Good. Yes.
Do we get the final exercise?
Yeah, the idea would be that next week we try to get the final assignment.
Is that exercise 6 or is it?
It's a separate one, so there will be exercise 6, which will be kind of normal exercise, and then there will be the final assignment. And the final assignment is such that you will have time to do that until, well, last year we had it like mid-January basically was the final deadline. So you have some time, because it is basically going to be a bit broader task. But yeah, we will tell more when we have that done. Yeah.